Alright, hi all. We're going to start with a few problems that'll help you with the homework assignment I'm going to give at the end of the video. So these are all from your textbook, page 115, numbers 36 and 38. The directions: write the equation of the line tangent to the given function at the given point. Equation of the line, so we're going to use our point slope form. 36 f of x equals 3 times 5 minus x quantity squared at the point 5, 0. Okay, we have something being squared, so we're going to need to expand our function before we can use the power rule. First term squared, double the product, square the last term, distributing that 3. Alright, well, we know the basis for the equation of the line. Y minus 0 equals our slope times x minus 5. We know the slope comes from the value of the derivative at 5. So now we can use our power rule. Derivative of 75 is 0. Derivative of negative 30x is negative 30. Oops, I skipped a step here. Plus 3x squared. Sorry about that. Derivative of 3x squared is 6x. So now when we plug 5, well, isn't this convenient? Our slope is 0. Plugging that in, the equation of the line would be y is equal to 0. Because everybody loves trig. G of t equals negative 2 cosine of t plus 5 at the point pi comma 7. Alright, g prime of t. I don't need to do anything to the function as far as expanding, breaking up fractions. Derivative of cosine is negative sine t. Derivative of 5 is just 0. So g prime of t is 2 sine of t. G prime of pi, this is going to come out to 0 again. Alright, if my slope is equal to 0, then the equation of the line is just going to be 7. Alright, this isn't bad for the next problem I'm going to do. If I have a line that has a slope of 0, what does that line look like? It's a horizontal line. Furthermore, if we talk about the slope of the tangent line being 0, then what this tells us, there's a horizontal tangent line at the point of tangency. Alright, so that's actually a very important relationship. So it's good that we're seeing these two examples where the slopes of the tangent lines came out to be 0. Okay, so now page 116, number 60, determine the points, if any, at which the graph of the function has a horizontal tangent line. Okay, that's our clue. A horizontal tangent line occurs when the derivative is equal to 0. Okay, the last two examples we just looked at, we found both of those equations of lines to have slopes of 0. Alright, so the function is x cubed plus x. So I need to find the derivative of my function. Y prime, using my power rule, 3x squared plus 1. A horizontal tangent line exists if the derivative is equal to 0. So subtracting 1 and dividing by 3. Attempting to solve this wouldn't work. So what's our conclusion? There's no horizontal tangent line to the given function. Okay, so to complete the notes for section 2.2, rates of change, we all know the relationship distance equals rate times time. If we look specifically at that r, if we solve this equation for rate, the rate is the distance over the time. And we're very familiar with rates, distance over time. You know, miles per hour, any type of change in distance, okay, over some unit of time. We look specifically at the average velocity. So the average rate of change would be the change in the distance or position of a function over the change in time. All right, position functions in our textbook are represented with s of t, or you could see a position function represented as x of t, all right, depending on the textbook that we're looking at. All right, so given the position function, s of t equals negative 16t squared plus 100. First, find the average velocity over the interval from 1 to 2. This interval represents our units of time. So it's saying from 1 to 2 seconds, let's find the average velocity. Okay, so average velocity is the change in position over change in time. This should look familiar, change in y over change in x. We're just finding the slope of the line connecting the points at 1 and 2. So s of 1 minus s of 2, all divided by 1 minus 2. S is our position function. When I plug 1 in, negative 16 plus 100 will give me positive 84. When I plug 2 in, 2 squared is 4 times 16, negative 64 plus 100 gives us 36. 1 minus 2 is negative 1. So the average velocity is negative 48, and then the units for this would be feet per second. So for those of you that are in physics right now, the negative 1/2 gt squared plus initial velocity plus initial height. When your acceleration due to gravity is 32 feet per second, then I know that's where my units come from. We'll talk more about units as the year progresses, but if you didn't know that, that's fine. I gave that to you. All right, so since the velocity is less than 0, I'm going to try and have you answer this. Try and describe the motion of the particle, knowing that the velocity is 0. Okay. Oh, that's not what I wanted to do yet. Okay, so if the average velocity is the change in position over the change in time of a function, then the what we call instantaneous velocity is the limit as the change in time approaches 0 of the position function. Okay, so let's talk about this instantaneous for a moment. The average velocity, in the example we just did, between 1 and 2 seconds, this is the average rate of change of the particle. Well, what if I want to know the velocity of the particle at exactly 1 second or exactly 2 seconds? That's what the instantaneous velocity tells us. At any given moment, what's the velocity of the object? When you are asked for when you're supposed to find instantaneous velocity, it's just asked as the velocity function. If you're asked for the average velocity, average will be included in the question. So let's interpret this. Velocity, notation for velocity is v of t. This should look familiar to you, right? This is your definition of derivative. But what function are we finding the derivative of? The position function. So the velocity, the instantaneous velocity, is the derivative of the position function. Again, I know not everybody's in physics, but velocity can be any real number. Okay, velocity can be positive, velocity can be negative, velocity can be 0. When you're asked about the speed of a particle or a function, the speed can never be negative. So the speed is always the absolute value of the velocity. All right, so let's use this relationship. The velocity is the derivative of the position function.